If you've ever wondered what the difference between supervised and unsupervised learning is in machine learning, then you're watching the right video. Maybe your teacher just didn't explain it very well, or maybe you just never grasped the concept, but in the video, we're going to go over these two basic concepts and as well help you understand them a little bit better. Hey everybody, welcome back to the channel. My name's McKay. If you're new around here, I'm a data analytics student with an interest in machine learning. And on this channel, we study the tools, tech, tips, and different strategies that can help us become better data scientists and develop our work in analytics. Today, let's talk about supervised and unsupervised learning. These are two really basic concepts and really the two core foundations of machine learning. We'll start off talking about supervised learning, and then we'll jump into unsupervised learning, the differences kind of between the two, and then we'll jump into, at the end, how we know which model to really use. All right, so looking at supervised learning, this is when the model, the algorithm, is going to learn by example, or it's going to learn by historical and previous data. So what it does is it uses labels to make predictions from historical data on future data. So really there's two types of supervised learning methods. The first one is called regression, which you may be familiar with, such as terms as linear regression, or logistical regression, polynomial regression if you come from a math background. And then the other one is called classification. In regression, what we're trying to do is we're trying to predict numerical values, essentially. We're trying to make predictions on things such as age, weight, height, salary, price of a home, stock market predictions. A lot of those different things that have a numerical value to them. Classification is a little bit different because what we're doing in classification is we're making predictions on data which can be classified as yes or no, pass, fail, that kind of data. So we're not really making a prediction on a salary or on a numerical type, but it's rather a binomial categorical type. So if we look at an example of supervised learning, what we can do is we can take these fruits, for example. We're going to have apples, bananas, and oranges. Some of the apples might be red, orange, and green. And literally what we're doing in regression is we're just making a prediction based on the previous data. So with supervised learning in the data, we already know the characteristics of an apple, of an orange, and a banana. And so this data and the model are going to help use the inputs and the outputs to make prediction on future fruit that we put into the model, for example. So it's already going to know what an apple is, the characteristics of it. It's already going to know what an orange is. It's already going to know what a banana is. And then when we throw a banana at it, it's going to say, oh, hey, that's a banana. Throw an apple at it, oh, hey, that's an apple. This really is what we mean by when the data is labeled and it's learning from example. It already knows what everything is, so when we throw new stuff at it, it's going to be able to make predictions on that. So now that we have a good idea of what supervised learning is, let's jump into unsupervised learning. So unsupervised learning is actually a little bit different, and it's what people probably think of when they think of machine learning, and this is where the machine is learning by itself. I mean, it's a typical iRobots situation where the robots and the machines are just learning and they're going to take over the world someday. Not really, but you get the point. So compared to the data with supervised learning, in unsupervised learning, we actually have no information about the historical data. We don't know what is an apple, what is a banana, what is an orange. And what unsupervised learning aims to do is it aims to find patterns and unidentified trends in the data to be able to make predictions and make assumptions about the data. So with our fruit example, it might look at all the different type of fruit, and it might look at color and say, well, all these are different colors, so they must all be different things. Maybe it looks at shapes and it says, hey, the apples and the oranges are the same shape, maybe those are the same thing. And it kind of helps us find patterns and trends in the data that maybe we just didn't see before. Really, there's a lot of cool possibilities with unsupervised learning, but you need to make sure that you're using it correctly, or you might end up making predictions that really just aren't true. So now that we have the differences down of supervised and unsupervised learning, you're probably thinking to yourself, okay, like now what? How do I know which one to use when I'm wanting to deploy a model and create like an actual algorithm? So there's 4 steps that really, when you're creating an algorithm, you should be looking at. The first one is you need to look at the data. You need to look at what kind of data you have, if that data is going to be better suited for a supervised or unsupervised learning model, if it has labels, if it's just a bunch of like text data. And then after that, you're going to need to determine what your end goal is. What are you trying to predict? Are you trying to predict stock market prices, or you're trying to predict house price, or you're trying to identify malware in a system. The two differences in the models are really going to help you understand the difference between what you're trying to achieve. And then you need to look at which algorithms are actually available. Do you want to use linear regression? Do you want to use polynomial regression? Do you want to use some type of clustering? Knowing which algorithm you're going to use is going to be a lot more beneficial when you know exactly what you're trying to get done. So if you're trying to make stock market predictions, there's a ton of available research and previous papers, models, etc. that you can look at and find on stock market research. So hopefully by now you understand the difference between the two, between supervised and unsupervised learning. It's really important to grasp these concepts if you're interested in machine learning, as they will help you understand models better as well as deploy the correct algorithms. If you like this video, be sure to check out this playlist right here. It has a bunch of data science and machine learning topics you'll probably be interested in. And that's it for this video, everybody. Thanks for watching. Be sure to subscribe if you haven't, and I'll see you in the next one.